Okay, example 2, Ming has $4.45 in quarters and dimes. So this time we're dealing with quarters and dimes, and this time the value is $4.45. So quarters, dimes, value, number. All right. So whatever the number is, I always just pick variables that represent the currency we're using. So quarters and dimes, I'm going to use Q and D. I always use N for nickels, H for half dollars. I might use S for silver dollar. So, F for $5 bill. T for $10 bill. They usually stick to coins though. Pennies, nickels, dimes, quarters, half dollars. And the value of these things again is based on the value of the currency. We're always going to do value in cents. So every quarter is worth 25 cents. We have Q of them. So 25Q is how much the quarters are worth. Every dime is worth 10 cents. We have D of them. So 10D is the value of the dimes. So looking at the two facts they gave me, fact number 1 is she has $4.45 in quarters and dimes. So the value of the quarters plus the value of the dimes is equal to the value of the coins. And again, that's $4.45, so we're going to go with 445 cents. We move the decimal point 2 spaces to the right. Fact number 2, she has 8 more quarters than dimes. What does she have more of?
Quarters.
Quarters. So if I wrote Q equals D, which number there is bigger?
Q.
How much bigger?
15 cents bigger?
No, we're talking about
Plus
number of coins, not how much they're worth.
Oh.
It says 8 more, right?
Yeah.
So this is exactly 8 more than that, right? So D is smaller. So to make this equation true, I have to take the smaller number and add 8 to make the bigger number, right? Q equals D plus 8. Once again, elimination and substitution are up as options of what we're going to do. Once again, look at the blue equation this time. 25, 10, 445, everything divides by 5 again, right? Not a coincidence, happens every time, or almost every time. So if I take this equation, divide everything by 5, I'm going to get 5Q plus 2D is equal to 89. Those two equations, what I've got boxed up here in blue and what I got written down here in blue are equivalent because I divided everything by the same amount. It's not a requirement to do that, but anytime you can make numbers smaller, it makes the problems easier to do. So it's worth considering. Looking at this problem as far as what technique would it be better, it looks like substitution's a better one for this one because we're told that Q has an expression D plus 8 that's equivalent to it. So I can take the Q out of this and replace it with D plus 8. If I do that, I'm replacing one object Q with multiple objects D plus 8. So when I substitute, it's going to look like this. 5 parentheses D plus 8 plus 2D is equal to 89. As always, if you replace one thing with multiple things, parentheses around the multiple object replacement. We multiply 5 through the parentheses. To simplify, we're going to get 5D plus 40 plus 2D is equal to 89. I'll move the 40 over to the right. Combine like terms, 5 and 2 make 7D. 89 minus 40 is 49. Divided by 7, we get D equals 7. So we end up with 7 dimes. Our job is to find number of dimes and number of quarters, right?
There are 15 quarters.
And how do you know that, Parker?
Seven
Because
plus
I
there's
added
8
7
more
plus
quarters.
8.
All we have to do is go back here. If there's 8 more quarters, take the dimes, which you found 7, add 8 to get Q, so 15 quarters. Once again, we can verify our solution if we want to. We just take the facts we just figured out. 7 dimes is worth 70 cents. And 15 quarters is worth, let's see, that's $3.75. 5, 4, carry the 1, $4.45. It's the correct amount of money. We're supposed to have 8 more quarters and dimes, which you can see very clearly we do have. So that tells us that our answers are correct. Set up the system of equations, then let the structure of the equations allow you to do either elimination or substitution. Do the one that's easiest to do. Don't always use one. Use whichever one's easier to use for the structure of the system. Good habit to start.